Hello, my name is Dr. Weber. Today I'm going to work through a circuits problem with you. I've got that circuit right behind me here. I have a circuit that's being supplied with 10 volts from a power source, and I have 3 resistors in my circuit. The first resistor has a resistance of 30 ohms, the second resistor has a resistance of 50 ohms, and it is in parallel with a third resistor of 100 ohms. And the goal of this problem is to calculate, well, we want to find the total resistance of our circuit, and we also want to calculate the current and the voltage across or through each one of our individual resistors, and we also want to do the same thing for our whole circuit. Okay? And in order to do that, we have some important rules, 6 of them here that we want to keep in mind. When we have resistors in series, the current through all those resistors is the same, the voltage drop across them must add up, and the resistance must sum up together. If we have resistors in parallel, the current sums up, so that the total current through all of our resistors in parallel is the sum of the current through each of the individual resistors. The voltage drop across our resistors in parallel is the same, and the resistance we calculate the equivalent resistance as 1 over the total resistance equals 1 over R1 plus 1 over R2 plus so on. Okay, so the first order of business is to calculate here our equivalent resistance for our circuit. And so what we can do is we can combine these 2 resistors here that are in parallel into one resistance and call that an equivalent resistance, R23. And then that resistor, R23, will be in series with our resistance, R1. Okay, so let's calculate the equivalent resistance for these 2 resistors in parallel here. So 1 over R23 equals 1 over R1 plus 1 over R2. So that equals, 1 over R2 plus 1 over R3. So that equals 1 over 50 ohms plus 1 over 100 ohms. And so we take 1 divided by 50 plus 1 over 100 and take the inverse of that in order to get our equivalent resistance, R23, which we find to be equal to 33.3 ohms. Okay, so if I were to redraw this combination of resistors, it would look something like this. I'm going to draw it over here. So I have my first resistor, R1, with 30 ohms of resistance, in now series with my equivalent resistance, R23, which is the combination of these 2 in parallel, and that has a resistance of 33.3 ohms. Now when resistors are in series, the resistance adds together, so if the total resistance of this circuit is going to be the sum of R1 plus the sum of the equivalent resistance for our 2 resistors in parallel. So our total resistance is going to be 30 ohms plus 33.3 ohms equals 63.3 ohms. Okay. So now we can use this equivalent resistance for our whole resistor in order to calculate what is the total current flowing through my circuit. Okay, so we can use Ohm's law to get that for us. So if we know that V equals IR, then we know that the total current is equal to the total voltage supplied by our power source divided by the total resistance. So this is going to be 10 volts, that's the voltage supplied by our battery, divided by 63.3 ohms. And so the total current within our circuit is equal to 0.158 amperes. So I'm going to fill that in my table here. 0.158 amperes. All right. Now, we know, again, from our rules for resistors in series, that the current flowing through resistors in series is the same. So if my equivalent resistance for all of my resistors together in my circuit is 0.158 amperes, then that means that the current running through resistor 1 is also 0.158 amperes. And then the current running through my equivalent resistor R23, is also 0.158 amperes. Okay, now we can use this information in order to find the voltage drop across these resistors, R1 and R23. So we again use V is equal to IR. V1 is equal to the current through resistor 1 times the voltage drop across them. Oh, sorry, times its resistance. Okay, so then that's going to equal 0.158 amperes times 30 ohms. So the voltage drop across my first resistor here is equal to 4.74 volts. 4.74 volts. Now, we know that the total voltage across my resistors in series equals the voltage drop across my first resistor plus the voltage drop across my second resistor, which in this case I'm representing as my equivalent resistor R23, okay? So if my total voltage is 10 volts, V1 I know to be 4.74 volts, then V23 has to equal V total minus V1. So that's 10 volts minus 4.74 volts. So the voltage drop across my resistors in parallel is equal to 5.26 volts. So R23 here is 5.26 volts. Now, we also know that for resistors in parallel, the voltage drop across them is the same. So if the voltage drop across my equivalent resistor R23 is 5.26 volts, then that's the voltage drop across R2, also the voltage drop across our R3. All right, now I can use that information in order to figure out what is the current running through resistor 2 and resistor 3. So again, starting from Ohm's law, V is equal to IR, the current running through resistor 2 is equal to the voltage across resistor 2 divided by the resistance. And so that's going to equal 5.26 volts divided by R2, which is 50 ohms. So the current through our second resistor is equal to 0.105 amperes. 0.105 amperes. And we do the exact same thing for resistor 3. So the current through resistor 3 is equal to the voltage drop across resistor 3 divided by the resistance of resistor 3. Okay, so that's equal to 5.26 volts divided by 100 ohms. Current through resistor 3 is 0.053 amperes. 0.053 amperes. Now, let's check ourselves here. We said that for our resistors in parallel, that the current has to sum up together across them. So the total current moving through our equivalent resistor R23 was 0.158 amps. No, so if amperes. So if I add the current through resistor 2 plus the current through resistor 3, I should get back 1.158 amperes, which I do. If I add 0.105 amperes plus 0.053 amperes, I get back 0.158 amperes there. Okay, and so starting from my circuit, breaking it down into finding its equivalent resistance in order to find the current running through it, I'm able to then back out from there to find the current and voltage drop across each of my individual resistors in this circuit.